All right, friends and neighbors, welcome back to the final video for CCNA Chapter 1. So this will be video 3 out of 3. So just to recap where we were before, right? We had just finished talking about the post office example, which is really a discussion of, sort of how routing for IP packets works in the internet. All IP packets have a source and destination IP address, so they can get there by themselves, but in order to get from one network to another, we need to send them from one router to another. And the routers can communicate with each other and send traffic to each other just like post office branches can send to the main office and so on. And that's how we distribute mail, and that's how we distribute packets as well. Now we're going to sort of return to the letter analogy later on in this video, but suffice it to say that right now in the internet we have tons of destinations, lots and lots of routers to get us to all those places. And a collection of routers will be run by, say, an ISP, and then lots and lots of addresses. And what we're also going to find out is that there are lots and lots of different kinds of addresses, and we have lots of ways to organize those addresses. We should also remember what an IP address looks like, right? We have the dotted decimal notation where each one of those numbers is represented by 1 byte. So we call it the dotted quad or octets. So each number in an IP address can range from 0 to 255, and we'll see what those really mean later on. So let's finish our model discussion, right? The whole point of chapter 1 is to get you used to some terms and things like that. So let's get down to layer 1 and layer 2, and these are called the data link and the physical layers. And what we'll find out is that these two layers work very closely together. And it's very, very common for a local area network protocol like Ethernet or 802.11 to sort of be in charge of both of them. So it turns out also that the IETF, the RFCs, don't really have much to do with what goes on at layer 1 and layer 2. They describe what should happen there, but the standards that we almost always use come from the IEEE, the Institute for Electrical and Electronic Engineers. That's a different standards body. That's a different group that manages all of those. And we sort of plug those into our TCP/IP model all the way at the bottom. Now, historically, there have been a lot of local area network protocols, but today we're really down to 2, Ethernet and 802.11. Now, there is another protocol that operates down there at layer 2. It's sort of a bridge between layer 2 and layer 3, and that is the Address Resolution Protocol, or ARP. I'll just mention it now. We're going to talk a lot about it later on in this series, but it lives down there at those lower layers. So if you remember the graphic that we've been using, right, it's all the layers of the 5-layer TCP/IP model. So we're down there at layer 1 and layer 2. And to quote from the book, right, protocols and hardware required to deliver data across some physical network. Okay, so let's think about this for a sec. We take PCs, we wire them into switches or to the switch ports on your wireless home gateway. We take that switch and we wire it maybe to a router. And these are cabling. You know what? Here's an example, right? We take Ethernet cables like this. Now, the only reason these are called Ethernet cables is because we're running Ethernet over them, right? That's the protocol. But really, this is just unshielded twisted pair wire. It's copper wiring terminated with an RJ45. Okay, so this is what we run everywhere. Now, the construction of this cable, the pinouts that we use, how the individual conductors inside are connected, the voltage that we use, the shape of the connectors, these are all physical layer concerns. Right? What is the electricity that we're going to run over here? What does the signal look like? All of those are physical layer concerns. And so the physical layer is very much concerned with those electrical and mechanical standards that we use for something like this. But the data also has to be organized in a particular way. Now I'm going to use the word frame right here. We're going to use this many, many times. But we send frames, right? That's just an organizational structure for how we put the ones and zeros together. We're going to send Ethernet frames over this particular network. So from my PC to the switch decides what to do, and then from the switch to the router, and so on. And then also vice versa. So when we get back to our packets, we can see at the bottom of the slide here, I've got Ethernet, but I can also see that there are these MAC addresses here. So something that we have to be aware of is that layer 2 has the concern of not only building the frame, but addressing the frame. So we have MAC addresses at layer 2. And then, of course, this is all going to be handed up to layer 3. And we're going to decode the packets, or we might be doing the reverse. If we're sending data, I might take a packet and put it inside an Ethernet frame to send it off. And in this particular case, my IP packet is carrying TCP. That's really what the layer 1 and layer 2 are all about. What are those electrical and physical characteristics that we need to convey data across the network, right? It's actual physical components and a physical signal that we're going to send that we all have to obey, right? The rules. And then we have this concept of organizing the data into some structure, some frame or format at layer 2. And it includes, among other things, MAC addresses. Now, another important idea from chapter 1 is the idea of encapsulation. So we have the stack right above me here. And so if you imagine that you're using some kind of application, email, text, a web page, whatever it is, and you have data, right? User data. Well, you want to send that across the network, and so you send it down to the transport layer. The transport layer adds the ports, adds some additional fields, and then gives it to the IP layer. And then that moves down to the link layer, which we now know is going to build an Ethernet frame, for example. Well, this concept is called encapsulation. And so if you rearrange the layers a little bit, you can see exactly what we mean by this. So the data is encapsulated in TCP or UDP, and that is encapsulated inside IP, and that is encapsulated inside Ethernet or 802.11. Now, there are some keywords and tricky phrases here. We say data to start off with, but when we give it to TCP or UDP, we're usually talking about something called a segment. And then when we give it to the IP layer or the network layer, we're talking about packets. When we pass it down to layer 2, we're talking about frames. So whenever you hear in this series or you're reading and you see the phrase or the word frames, you know that's a layer 2 thing. When you see packet, you know that's layer 3, and when you see segment, you know that that's layer 4. When you're sending something, you encapsulate on the way down the stack. So that should make sense so that you can send it across the network in an Ethernet frame. But when that Ethernet frame is received, the exact opposite process happens. You open up the Ethernet frame and get rid of it. You open up the IP packet and then you get rid of it. You open up the TCP segment and you get rid of it, and then you have the data. Now we'll see why all of that is necessary later on, but the important thing to remember right now is that we do this process of encapsulation and de-encapsulation, and then also we have the words frame, packet, and segment. If we put this whole thing together, we've got two major models that we talk about. The OSI model, which is also called the reference model, 7 layers. From a practical perspective, we really have the RFC 1122 TCP/IP model. But the TCP/IP model isn't exactly accurate either, in the sense that we say that it's got that 5th layer down there at the bottom, right? Physical layer, but really we glue those two together. So operationally, perhaps a more accurate or precise way to talk is we've got whatever our local area network protocol is going to do at layer 1 and layer 2, and then we've got IPv4 or IPv6 at layer 3, TCP and UDP at layer 4, and then whatever our application protocols are going to be. So that's why we sometimes draw this in this fashion here, where we have 3 different ways to represent our model. But importantly, whatever goes on at layer 1 is consistent across the models. Whatever goes on at layer 2 is consistent. Whatever goes on at layer 3, and so on. Now, as just a sort of foreshadowing here, what we're going to find out is that the addresses that we talk about, MAC addresses, IP addresses, port numbers, they exist at different layers too. Then we'll also find out that equipment, switches, routers, they exist at a particular layer as well, because their jobs are about forwarding traffic at that particular layer. Okay, so I recognize that many of you may want to work faster than I am in this series. So at the end of each chapter, I'm going to have a look ahead at the next chapter so you can jump ahead. In addition, I'm going to include in the show notes a collection of videos that you might watch if you want to get ahead and watch, some high points of a particular idea. So I'm going to do that with Ethernet here in this particular case. I will also periodically put together a collection of chapters in one look ahead video. So I just put one out there for chapters 1 through 5. So you can look at those links to those videos if you want to have something else to use as a resource in addition to the chapter. Now, I suppose I should explain that a lot of the videos that I've done were for other books. So these are books that I wrote some time ago, and I'm not telling you you should get these books. I think they're free online now, or the PDFs are available. But a lot of the videos will be entitled, something with core network protocols or routing and switching. It's because they go to chapters for other networking books that I wrote for this stuff. But they're great content, and they'll fall right in line with some of our chapters here. So the look ahead into chapter 2 is really the role of network components, in this case, switches. We're going to talk more about Ethernet and how it works. We'll talk about some Ethernet topologies, especially for small office, home office networks. And then we're also going to talk about some of the physical interfaces, just like the cable that I showed you, and some of the cabling types. So we talk about fiber and copper, but there's more than one kind of fiber and there's more than one kind of copper out there. And all of these links will be in the show notes for a good place to start on Ethernet if you want to jump ahead instead of just reading the chapter. Okay, so that completes CCNA Chapter 1. It was an overview of TCP/IP and the OSI networking models. Remember the general idea of IP routing, right? The post office example. And of course, we added some terms to our vocabulary: segment, packet, frame, encapsulation. And we talked a little bit about what goes on at the different layers in each one of the models. We also took a look at some captures. Well, like and subscribe if you're doing okay so far. May those packets always reach their destinations. And remember, this is networking and certification. You can do this.